In this video, we're going to be equating coefficients, which is an alternative method to polynomial long division. In this example, we want to divide this polynomial by this divisor, and we could use polynomial long division, but I'm going to show you an alternate method. We know that this polynomial, 2x to the fourth plus 5x cubed plus 4x squared plus x, should be equal to this divisor times something. Okay, so if I divided this by this divisor, the result that I get, the quotient, would be this value here. And so if I multiply this by some value, I should get this. What you need to realize is that this is to a power of 1, and whatever x value we have here, they have to add up to be 4. So I know that when I multiply this, I'm going to need to multiply it by something that has an x cubed in order to come out with an x4 as my highest term. Once you know that, all you're going to do is account for every single term, and we're going to put a letter in front of this. We usually just use a to account for each one. So this is going to be ax cubed. We're going to say bx squared plus cx plus d, and this is 3, 2, 1, and this would be our constant term without x. You have to account for all of them. The other thing is you have a remainder, or you have the possibility of a remainder. We don't know if we divide this by this divisor whether we're going to come out with 0 or remainder, so we have to account for that. And the rule for the remainder is it's going to be, we're going to use 1 degree less than the divisor. So since this divisor is linear, it has a power of 1, my remainder can just be r. And I'll show you a different example here in a minute. But you need to remember that the remainder is going to be 1 degree less than the divisor. And the divisor is what they're asking us to divide by. So that's this term. And so now, actually guys, I should really have an identity here because this says for any value of x I plug in on this side, I must get the same thing on this side. So really this is a symbol for an identity, but it works the same way. I'm going to multiply this side out. 2x times ax cubed is going to be 2a, and then x cubed and x is going to give me x to the fourth. Then I'm going to multiply this 2x by the bx, and I'm going to get 2bx cubed because there's 1 here and there's 2 here. And then 2x times cx is going to give me 2cx squared because there was 2 x's. And 2x times d is going to give me 2dx. And I'm just putting the letters in front of the variables. Now I want to multiply the 1 by each one of these, and 1 times ax cubed is just ax cubed. 1 times bx squared is just bx squared. I'm going to get cx and d, and then I have to remember to put plus r. Now that looks like a lot, but all we're really going to do is find our terms that can be put together, our like terms. This is the only term with an ax to the fourth, so 2a, which is the coefficient of this term, must be equal to whatever the coefficient of our x fourth term over here was, which is 2. And if I divide, I can say that a must be 1. So I'm going to cross this one out now that I've used it so that I don't get confused on which ones I've used. This has an x cubed and this has an x cubed. So I'm going to take the coefficient. I'm going to say 2b plus the coefficient of this one, which is a, must be equal to this 5 because that is the coefficient of my x cubed term over here. Now I already know what a is, so I'm going to plug this 1 into a. I'm going to say 2b plus 1 must equal 5, and I'm going to solve using basic algebra. And then I'm going to divide, and so now we know that b must be 2. Cross these out because we've used them. This is an x squared term, and this is an x squared term. So I can say that 2c plus b, and I'm just taking this coefficient and this coefficient, must be equal to whatever my x squared term over here is, which is 4. And again, we've just found b, so I'm going to plug that in. I'm going to say 2c plus, in place of my b, I'm going to put this 2 here, equals 4, and I'm going to subtract. And I get 2c equals 2. And when I divide, I get that c is 1. And so I've used this one and this one now, and now we're going to do our x terms. The coefficient of this one is 2d, and the coefficient of this one is c. And those must be equal to the term, the number in front of x, which in this case is 1. And so again, we happen to know c, so we're going to say 2d plus, in place of my c, I'm going to put a 1, must equal 1. Well, when I subtract this here, I'm going to get that 2d is equal to 0. And when you divide, d is still equal to 0. Okay? Now I need to figure out we know what d is, okay, but we need to figure out a remainder. So what we're going to say here is neither one of these two terms have an x. These are constants. So we're going to say that d plus r must equal our constant term. And in this case, there was no constant term, so you have to be careful with that and make sure you account for everything. This would be 0 because I don't have a term without x in this polynomial. And so now we know d is 0. What must r be in order to make this 0? R must also be 0. Okay, so our remainder is 0, but you need to make sure you do that because a lot of times you won't have a remainder of 0. All we're going to do now is take the letters that we just found, the values that we just found, and we're going to plug it into this. So we're going to say 1x cubed, because I plugged the a. This was our a value. I plugged it in here. And I'm going to say b was 2 plus 2x squared. This was our b value, plus 1x. This was our c value. And then d is 0, so I'm not going to put plus 0. And since I have a remainder of 0, I'm not going to put that. So this is our quotient. This is our answer. If I divide this polynomial by 2x plus 1, this is the result. It's what I get, what I have left. Okay, on this example, we're dividing this polynomial by this binomial. So again, I'm going to take x to the 4th plus 3x cubed minus 8x squared minus 27x minus 9. And I'm going to use my identity symbol because when we're done with this, this side should be equivalent to whatever I get on this side for any x value that I plug in. But I'm going to use this identity symbol and say that it must be the same as x squared minus 9 times some value. This must be multiplied by whatever we have here in order to result in this polynomial. So I have an x squared. I need to figure out what power of x I need here. So these two powers have to add up to be this 4 for my leading term. So x2 and x squared is going to be a power of 4. I'm just going to put an a in front of it. Once you know that, you have to count for everything below it. So ax squared plus bx plus c, 2, 1, 0. Again, I have to account for a remainder in case there is one. And the rule for the remainder is we're going to use 1 degree less than this divisor, whatever we're dividing by. 1 degree less than x squared means I'm going to have a remainder possibly with an x in it. And just like we did here, we have to account for everything below it. So this is x to the 1. I must have a number without x. And you can use any letters you want. Once you have this, you're just going to multiply this out. X squared times ax squared is going to be ax to the 4th. X squared times bx is going to be bx cubed. X squared times c is cx squared. And I'm going to do the same thing with the negative 9. Negative 9 times ax squared is negative 9ax squared. Negative 9 times bx gives me negative 9bx, and negative 9 times c is negative 9c. Don't forget to bring down your rx and your s. Okay, this is my only term with the exponent of 4 on the x, so it must have the same coefficient as whatever this term did. So we know already that a is 1. b, let's cross this out so we know we've used it. Bx cubed must have the same coefficient as whatever my x cubed term was. And notice in this case there was no other x cubes to combine it with, so b must be this 3 here. I've used this one. Now I do have more than one x squared term. This is c, this is negative 9ax squared. So we're going to take just the coefficients, the c and the negative 9a, and say that that must be equal to my x squared term here, which has a coefficient of negative 8. I already know a, so I'm going to rewrite this and I'm going to plug in that 1 for a. And I'm going to solve this. And this is going to give me c is equal to, this is negative 9, and when I add it to the other side, I'm going to get 1. So c is 1. I've used these two now. Negative 9b in front of an x term, and rx, so plus r, is going to give me the coefficient that occurs in front of my x term here, which is negative 27. Okay, so now I know what b is, and I need to plug that in. So this is negative 9 times b is 3 plus r must be equal to negative 27. And this negative 9 times 3 gives me negative 27. So you guys can figure this out, but if I add the 27 to both sides, I'm going to get that r equals 0. These two I've used. These are my constant terms. They have no x values, so I'm going to say negative 9c plus s must be equal to my constant term here, and in this case, it's negative 9. Again, I'm going to plug in c, which we found to be 1, so negative 9 times 1 plus s equals negative 9. And again here, when I do this, add 9 to both sides, we're going to find that s is in this case 0. So when I do write my result, I'm going to take what we had here. This would be our quotient. We were trying to find what these values were along with this remainder. So if you look at this, ax squared plus bx plus c, and really what we had was plus rx plus s, let's put our values in. We know that a was 1, we know that b was 3, and we know that c was 1. Now, r happened to be 0, and s happened to be 0, so I really don't need to write that. This is my result. This is my quotient. In this case, it didn't have a remainder, but we always solve for them just in case, because if this had it could have had a remainder of 2x plus 1. So we need to make sure that we account for it. But this is my answer.